All right. Now that we kind of have an understanding of what these parent functions are and how those key points operate, let's dig into an example of kind of how we will transform these types of functions. So you're going to see that the quiz that you're going to be taking goes pretty in depth in this and kind of covers a lot of the bases related to this. So um, the first thing we want to do is identify the parent function. And what you're doing here is the parent function is going to be one of the functions from this list. So is it squared? Is it cubed? Is it square root? Is it cube root of x? Or is it the absolute value of x? Which one of these does our function appear to look like? The best way to do this would be to kind of take away all the numbers. And if we get rid of the 1/2 and the negative sign and the +2, well, what's left? I'm going to give you guys a second to think about what that parent function would be. So we should have been able to identify that we see this, this square root symbol right here, which is going to tell us that our parent function is y is equal to the square root of x. So when I look over there, we can see this is what kind of, that's what's going on there, is that there's a square root there, so I know that it's the square root of x is going to be our parent function. And that also tells me, again, I know it has that ray shape, so it's 0, 0, 1, 1, and 4, 2 are going to be the key points of the function. So those are kind of my main key points. Now you might be asking, like, Nick, why do I need those? That's not my function. Well, what we do is we take these key points, we look at what's happening to this graph over here, and we're going to change these points by looking at what these different pieces are, okay? Now, it says list the transformations in a correct order. Notice it says in a correct order. So there's a couple different ways we could list it. I'm going to go just through one way. I'm going to teach this method consistently because I think it just makes the most sense to just learn one way rather than switching it up. In the correct order, list the transformations that have taken place in the parent graph to result to the function h of x. So when I look here, what we're going to do is we're going to start on the inside of the function. Now you might be like, Nick, what's the inside? Well, our function is the square root of x. Our parent function is the square root of x. So we're going to see, did anything happen underneath the square root? That's what I mean when I say inside, is that's kind of the inside of the function is really the key there. And we do identify that there is something going on there, and that something is a negative side inside of the square root. Now, you studied transformations in your videos in Unit 2, so hopefully, let's see if you can think about it. What would that transformation be? Take a look at your notes there. Pause if you want to check it. I would go look it up yourself. I mean, I know you're going to, a lot of you are probably just going to keep watching this video, but you're really going to learn this. I would pause, go look at your notes, answer this question. This transformation is going to be a horizontal reflection over the y-axis. And I want to show you kind of what I'm talking about there in terms of a horizontal reflection. So I'm going to pull a Desmos graphing calculator over here. And let's take a look at what I'm talking about here. So this is really big. Let me shrink this. Sorry. Thanks for bearing with me. Okay, so I'm going to type in, we're going to graph the square root of x. And we can see it has that ray shape. We can see our 4, 2 is our 1 point. We got the 0, 0, the 1, 1's right there. So what happens if I put a negative is we can see it reflects horizontally. You see that? So that negative flips that over, okay? So it kind of flips those x's and flips that graph over. So this is a horizontal reflection over the y-axis. All right, let's keep moving along and see if we can identify what else is going on. That's all that's happening inside the function. It's just the negative there. If there might be sometimes there might be a plus or a minus or a multiplication, something like that. But really all it's saying inside is we're going to flip those x values. Now we're going to take a look on the outside. Now when I look on the outside, we're going to see two things happening. I see a 1/2 on the outside and I see a positive 2. This is where that order kind of matters here. What we want to do is we want to take care of any multiplication before we take care of any addition or subtraction. Meaning, give you a second, do you know what that 1/2 would give you? If you don't, I'd encourage you to pause, go take a look at your notes, see if you can put it together. Hopefully we know that that 1/2 is what we will call, it's a vertical stretch or compression, okay? So it's going to affect the graph vertically. And since it's 1/2, since it's a fraction, a number between 0 and 1, this is actually going to be a vertical compression by a factor of 1/2. And then the last transformation is that +2. A lot of people do well with these just basic addition or subtraction ones. A +2 on the outside. A couple seconds to think about that. A +2 on the outside is a vertical shift. And then this one is going to be up 2. So a quick thing to cover is anytime you see multiplication, it's going to be a compression or a stretch. Whenever you see addition or subtraction, it is going to be a shift. Now that is both horizontally and vertically here, okay? So now we're going to kind of move on to the next step, which says, what operations would you apply to the x-coordinates of the key point of the parent graph to get the new points on this graph? This is when what we're going to be doing is x values are horizontal, right? So I look and my horizontal reflection is right here, right? So it's a horizontal reflection over the y-axis. So what that means is you're going to take your x value, and really we saw graphically that negative flipped it. So you're going to take all your x values and we're going to flip them over. If they're positive, we're going to make them negative. If they're negative, we're going to make them positive. So that's that horizontal reflection. Now it says, what operations would you apply to the y-coordinate to get this graph? So this is where we're going to kind of, what happens on the outside of the graph, the vertical stuff, really is as it appears. So the 1/2, we're going to multiply our y values by 1/2. That's how we apply that vertical compressions. We're shrinking those y values. And then we're going to add 2, okay? And just quickly to show you kind of really, I'm going to go back. So if we look at these, I like to show you these independently and graphically. So look at what happens if I put the 1/2 there. You can see that it kind of flattens this graph out vertically. It kind of compresses it vertically. So that 1/2 applies that vertical compression. And then you can see if I put a +2 on the outside, it just picks that graph up and moves it 2 places. And then Alex does a nice job of actually having you picking these graphs up and moving them. So now what we're going to do is we are going to take a look here and we are going to take those key points that we did up here in part B. So the first thing we're going to say is, okay, let's take those key points. Those are 0, 0, 1, 1, and the square root of 4 is 2. And now what we're going to do is we're going to apply these transformations. I like to think about this as this is kind of like the recipe that you will follow. So we're going to flip the x's, we're going to multiply the y's by 1/2, and we're going to add 2. So let's see what those would give us. So like this first one, it would be, I'll show the first one in detail. It's going to be -0, right, comma, 1/2 times 0 plus 2. Okay, so -0 is just 0. And then we work out that y value. Half of 0 is 0, plus 2 is 2. So that's going to give me the first key point on that graph. Again, 1, we're going to flip it over. We're going to make that -1. So it would be -1, and then 1/2 times 1 plus 2. Well, half of 1 is 1/2. 1/2 plus 2 is 2.5. So we can use a decimal here. That's okay. If you write it, I mean, 5/2 is the fractional version. And I actually think that's a little harder to graph, okay? Now our 4 is going to flip from a +4 to a -4. And then we'll work this. Half of 2, so we put this 2 right here. Half of 2 would be 1. 1 plus 2 would give us 3. And then really that is the new points of this transformed graph. So it's going to be, we're going to graph 0, 2 here. We're going to graph -1, 2.5. Here, I'm going to zoom in here so we can kind of really take a look here. It says to label your points too, so that's what I'm doing here. And then -4, 3, -1, -2, -3, -4, 1, 2, 3 is right here. And we can see that this graph's going to have that ray shape, and we flipped it over. So that's how we got there. I know this video is running long, so I'm going to just show you that. So check this out. So what we did is we're going to take our square root, right? We flip it over, right? We compress it. And then we shift it up too. And you can see that this graph looks a lot like the one I have right there. So that's the process. I know it takes a little bit of time, but I think you'll get this down as we continue to practice this.